So let's work out the equation of a circle, but we're going to do this ourselves because we've got enough information from what we've learned so far in our mathematics to derive the equation of a circle by ourselves. So let's have a think about what we want to do here. We're looking for an equation that tells us all of the points on this circle. Now, what do all the points on the circle have in common? We'll have a little guess here. We've got one of the points here, and we can see that that little purple dot will go round all of the points in that circle. So what's common about all of these points? We'll have a think about it. What is common to all of these points on the circle? Well, the thing that's common to them is that this little red line. So what is the red line? Well, the red line is the radius. So the thing that's common to all of the points on the circumference of that circle is that they're all exactly the same distance, that is the radius, from the origin. Now we can use that fact in order to derive an equation for a circle. Now what we want to do is remember our Pythagoras theorem. We know that if we were to drop the perpendicular down here, then we would have a little triangle. And in this triangle we could say that the x distance squared plus the y distance squared would equal the r distance squared. So that's just a statement of the Pythagoras theorem. So if this was 3 and this was 4, then this distance here would be 5, because that would be 3 squared plus 4 squared would be equal the value of the 5 squared. So we know for this point here, the distance from this point to the origin is going to be the x distance squared plus the y distance squared. And if we take the square root of that, we'll get this distance. But that's the same for this point up here. The x distance squared plus the y distance squared will equal this r squared. So we'll call that distance r for the moment. Now that's the same for every single other point on this circle. This distance squared plus this distance squared will give us this distance squared. So could it be that the equation of a circle is simply the value of the x squared plus the value of the y squared would equal the value of the radius squared? Now we'll find out just in a second, so whenever I put this in, if we're correct, we should get a circle drawn here. And we've got a value of r is equal to 1, and you can see it's drawn this circle in. Okay, so that's us worked out the form of the equation of a circle. So we can say that x squared plus y squared equals r squared gives us a circle of radius 1. So what if we wanted it to be a radius 2? Well, then we simply change this value of r to a value of 2. Now we've got a circle of radius 2. So now we know how to create a circle centred at the origin of any radius. But what happens if we take the circle and we don't have it sitting at the origin? We're going to move it to some other point in the plane here. Well, we've also got a solution to that because we looked at this problem whenever we were looking at manipulating functions. So now we know how to create a circle of any radius, but the only circles we can create are centred at the origin. Now what we want to do is shift the circle to a different point. So let's say we wanted to shift the circle of radius 1 to the point 2, 1. That would mean we would have to shift it 2 along the x, and we have to shift it 1 up the y. Now we've already seen this before whenever we looked at manipulating functions. If we had a function f of x and we wanted to shift it to the right by 2, we would create the function f of x minus 2. Minus 2 would shift it to the right by 2. And we could do the same with the y coordinate. If it was we had the function f of y, and we wanted to shift it up 1, we could create the function f of y minus 1, and that would shift us up by 1. So that means in order to move this circle here along 2 and up 1, we would just have to replace the x with x minus 2 and the y with y minus 1. So let's go ahead and we'll do that now. So I'll just turn the blue circle off for the moment. Now this is the circle that we have created here, which is the black circle. So we don't need that, we'll just pop this out of the way for the moment. So this is our own circle here, x squared plus y squared equals r squared, and we'll make the value of r equal 1. Okay, so that's our circle of radius 1. So we're going to shift this to point 2. So what we can do is we can change the value of x to a value of x minus 2. So we put it in the brackets and it would be x, and we would have to make it minus 2 all squared. So there we can see that we've taken the circle and we've moved it to the point 2. Now we want to shift it up to the point 1, so we'd have to change the value of y to y minus 1. So we'll go and do that now. So there we'd have y minus 1, and it would have to be all squared. So that's us taking the circle of radius 1 and we've shifted it to the centre here at a point 2, 1. So it means that we can move this circle round about the entire plane just by changing these two values here. So what we'll do is we'll change it and we'll give it some general value. So we'll say it's going to be x minus g, and we'll have a y minus f. So the centre of this circle is going to be an x coordinate g and a y coordinate f, so the centre is going to be gf. So we can move this circle round about, up, and we can move it left and right, so it means we can pick any point here to centre this circle. And of course we can change the radius of the circle as well by changing the value of our r. So that's us able to draw any circle of any radius and of any origin, any centre, anywhere on the plane. So we've derived the equation for our circle, and this is the equation here, x minus g all squared plus y minus f all squared equals r squared. So let's go ahead and we'll write out what we've learned so far, and we'll add a few extra equations which will help us solve lots of problems involving circles. So we've seen from the graphical calculator we've got our equation of a circle, which is x minus g squared plus y minus f squared equals r squared, and the g and the f will give you the centre of the circle, and the r will give you the radius of the circle. But we're not going to use it so much in that form. We're going to multiply these out and we're going to change the form in which we write the equation of a circle. So let's go ahead and we'll look at that next. So this is the form of the equation of the circle which we derived in the graphical calculator. Now what we're going to do is we multiply out these brackets and we simplify it, and we change it to a slightly different form. Now we're not going to go through the proof here of this, and it's an exercise that we can do in one of the exercises. So what we can do is we can multiply these out and it simplifies to this form here, x squared plus y squared plus 2gx plus 2fy plus c equals 0. So this is the equation of our circle, and the centre is going to be a value of minus g minus f, and the radius is going to be the root of g squared plus f squared minus the factor here of c. Now using this is best seen by example, so we're going to move on and we'll get a few examples done using the equation of a circle. So thank you for listening. I'll get you in the next video. Goodbye.